In section 3, we're going to take a look at graphing parabolas or graphing quadratics. We tend to call it a quadratic equation and talk about it in terms of quadratic, but when we talk about the shape of the graph, we tend to call it a parabola. So again, parabola equations when you have an x squared involved. The vertex, okay, so if you remember, a little bit too big. If you remember, a vertex is the point that's at the lowest here of a parabola, or if it's an upside down parabola, it's the highest or maximum point. So let's take a quick look here and then we'll practice some problems. Another terminology I want to mention is called the axis of symmetry. This line, vertical line through this vertex, where the left side is symmetric to the right side. You see they match up like a mirror. If you put a mirror here, they would match. That's called the line or axis of symmetry. And in this case, the equation's x equals -3. X equals, if you remember, is an equation for a vertical line up and down. And so that's the case here. In this case, we have a minimum value. The vertex is a minimum because it's below. Not below. It's the graph is open, the parabola is opening up, so it has a minimum value. If you take a look at the equation, it's x plus 3. We just finished transformations in the last chapter. So remember that would move it left 3 and down 2. So we see the vertex is at -3, -2. Okay. All right, so let's practice graphing. I've got another sheet, graphing quadratics, or in this case, giraffing quadratics. You like that? All right, here we go. We've already talked about this, but A, if you remember, is the number in front. For the record, this is called vertex form, because we are going to look at standard form as well. Okay, so if A, you remember if A is positive, do you remember what that does? It might stretch it or shrink it vertically. But if A is negative, do you remember that reflected it across the x-axis? So in this case, it's going to open down. H then is just the number that's there with the x, and k is the number afterwards. Okay. All right. So the first step is to identify each of these. So let's go ahead and do that here. What is A? A is 1. What is H? H is 2. K is 4. Now, which way does this open? It opens up. It's like a U shape. Okay. How did I know that? Because A is positive. Okay. So positive up. All right. And is the vertex going to be a max or a min? The vertex is a minimum value. You can see it's the lowest point on the parabola because it's opening up. All right, if we know h and k, we should know the vertex, right? So the next step is to find the vertex. In this case is 2, 4. We now need to pick some additional points, and then we're going to use that axis of symmetry to our advantage. So xy, I'm going to use 2, and I'm just going to use 3, 4, 5 from there. I'm just going to go up, get the next points. How do we find the y values? Well, here's where we're going to use our equation. Our equation was x minus 2 squared minus 4. Okay. And so all I have to do then is plug in the x values. So I'm going to take and plug in 3 for x. I'm going to plug in 4 for x, and I'm going to plug in 5 for x. So you see what I did? I just took this equation. This is y equals x minus 2 squared minus 4. 3 minus 2 is 1. 1 squared is 1. 1 minus 4, that gives me -3. Oh, I made a mistake. Did you catch it? I'm sorry. I said k was 4, but k isn't 4. K is negative 4. So this is 2, negative 4, 3, negative 3. Anyway, keep going here. 4 minus 2 is 2. 2 squared is 4. 4 minus 4 is 0. And then 5. 5 minus 2 is 3. 3 squared is 9. 9 minus 4 is 5. Oh, that's kind of nice. The next thing we need to do then is to graph this equation. So let's plot on my x-axis. There's 2, 3, 4, 5. And at 2, we're down at negative 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. So that's my range I'm going to need. So my first point is 2, negative 4. And you remember, this is the vertex. And it's a minimum value. I'm then going to graph 3, negative 3, 4, 0, and 5, 5. But you remember that axis of symmetry that goes through the origin? Or through the vertex? I'm sorry. In this case, the equation is going to be x equals 2. But you can reflect. Do you see if this point is 1 away, this direction, I should be able to go 1 point away this direction and get another point. Okay? So I'm going to clean that up a little bit. So I reflect that over. This point's 2 away this direction, so I'm going to go 2 this direction to here. And then here, this one is 3 away. 1, 2, 3. So I'm going to go 1, 2, 3 away this direction. And then graph the parabola. It's a little bit hard, but you want to try to keep this rounded a little bit and not a V like I did. Okay. So that's graphing quadratics when they're in vertex form. Go ahead and pause the video and do the next two. Hopefully you were able to get those. Here is the first one and the second one. I won't talk through these, but you could pause the video and look at these solutions. So this is graphing quadratics in vertex form. What if they're in standard form? Let's take a look at standard form. Standard form, we're going to go through a similar process. We're going to identify A, B, C this time instead of A, H, K. A is still going to be similar in that when it's negative, it opens down. Okay. And so let's take a look at this first one here. Here we've got A is negative 3, B, negative 12, C is 5. Does this one open up or down? Hopefully you said down, because A is negative, so it's going to open down. Since it opens down, we can see we're going to have a maximum value. The one thing you're going to have to remember for this section is there's a little trick to find the axis of symmetry. The axis of symmetry, it occurs at negative b over 2a. And this should be familiar for you. This is part of the quadratic formula. All right, so if we want to find the axis of symmetry, we can do that by saying x equals negative b over 2 times a. In this case, it's going to be 12 over negative 6, which equals negative 2. Now, if you think about this, wherever, I don't know where my parabola is, but I know it's centered on this line at x equals negative 2. Do you see that? Now, I don't know where the vertex is, but I now know the x value of the vertex. Okay, so I'm going to remove that little chart. If I know the x value, I can find the y value, right? By plugging in negative 2 into my equation. Negative 3 times x squared minus 12 times negative 3. Let me shrink this down. Right small. Plus 5. Okay, so I'm going to do that. I'm going to plug in negative 2 because that's my axis of symmetry. I now get positive 4, negative 3 would be negative 12, plus 24, plus 5. Did I do my math right? I think so. So 24 minus 12 is 12, plus 5 is 17. So that tells me that when x is negative 2, y is 17. So I know my vertex is at negative 2, 17. We're going to pick some points and reflect, just like we did before. We're going to take negative 2, 17 as my first one. Negative 3, negative 4, negative 5. In fact, I'm just going to copy this. Obviously, I'm not putting negative 2 in this time. But it's the same idea. I take this function and I plug in negative 3. I plug in negative 4. I plug in negative 5. So this is going to give me 3 additional points on my graph. And I'm going to plug it into my calculator here. Almost typed it in wrong. That doesn't help me any. 9 times negative 3 plus 36 plus 5 is 14. The next one, negative 3 times 16 plus 48 plus 5 gives me 5. The third one here, negative 3 times 25 plus 60 plus 5 gives me negative 10. So I can now graph these points. All right, here we go. Got a pretty good spread on the y-axis there, don't I? I would have saved myself some work if I would have gone the other way. If I would have done negative 1, 0, 1. But let's take a look here. Negative 2, remember, is the vertex. Alright, and then vertically, I think I'm going to go by 5s. So this is negative 10. Might not be quite drawn to scale, but I think you get the idea. So negative 2, 17. That's my vertex. Ooh, a little bit off. Oops, didn't want to get that. So that's my axis of symmetry. I've got another point here at negative 3, 14. Negative 4, 5. And negative 5, negative 10. And now we can reflect those. So I just need to put 1 this direction, and then 2 this direction, and then 3 this direction. All right. So the graph should look something like that. So, quick review. We need to identify our A, B, and C. Identify whether it opens up or down, and whether we have a max or a min. Then use negative b over 2a to our advantage to find the axis of symmetry, which you see is at negative 2. And then use that number to find our vertex. I plugged in negative 2 and got 17. Then we find a few more points. Once we have those, we can plot those on the graph, and then we can reflect across to get the other points. Go ahead and pause the video and try the next two. Alright, hopefully you did okay with those. Here's the second one and the third one here. You can pause the video, take a look. Maybe I'll zoom in a little bit for you. Although it's kind of hard to see them all at once, isn't it? Alright. This concludes this section. Great job, guys.